Morning, guys. Sorry that I can't be there with you today. Hopefully with this video lesson, it'll kind of feel like I'm there. We had our test on Friday, so that finished up our first unit. So we're going to move on to Unit 2 today, which is looking at quadratics. Today, the first thing that we're going to look at is factoring trinomials. This should hopefully be review for most of you. Remember that factoring is used to simplify expressions and to find the roots of an equation. Remember, the roots are the same as the x-intercepts. The first type of factoring that we're going to look at is common factoring. Common factoring is when something is divided from each term in the expression. It's from every single term that's in that expression. And this is the first type of factoring that you should do for any type of expression. So no matter what other types of factoring that we move on to, you should always start by doing this common factoring. So we're going to go through some examples. We're going to factor the following using a common factor, which is kind of what you did in the Bell work at the beginning of the lesson, where you found the biggest number or variable that you could pull out of the numbers. This time we're just going to take it one step further and actually factor that out of our expression. So we're looking at 5x plus 10. What is the biggest number or variable that we can take out of both of those terms? Hoping that one of you said that the biggest term was 5, that we could factor out of both of those terms. So if 5 is the biggest factor that we can take out, it goes out front, and we're going to put everything that's left over after dividing out that number put in the brackets. So if we take our first term here, our 5x, and we divide it by 5, 5x divided by 5 should leave us with, hopefully someone said, just an x. Then we look at our second term, it's a plus 10, and we're dividing by a 5, so 10 divided by 5, we should be left with a plus 2. So here we're finished. There's nothing else we can factor out. There's brackets, and whenever we're factoring, we always want our final answer to have some sort of brackets in it. So we have 5 bracket x plus 2, there's our common factor. Let's take a look at our second example here. What is the biggest number and or variable that we can take out of this expression? Hopefully you see that out of both of the numbers, let's start with them, both of the numbers, we can factor out a 3. We can divide out a 3 out of both of those numbers. But there's also something else that we can take out. Notice that there is an a in both of these expressions, so we can also factor out an a as well. So the biggest number and variable that we can factor out is 3a. So again, that factor sits out front, and then everything else gets put in the brackets once we've divided that out. So if we have 3a squared and we divide by 3a, let's start by looking at the numbers. 3 divided by 3, that should just leave us with a value of 1, because anything divided by itself is just 1. So we know that we should just have a single 1 there. But then look at the variables here. We have a squared and a, and we're dividing by a. So a squared divided by a. Think of it as a squared, that's 2 a's, because it's a times a to get a squared. That's 2 a's. If we divide out one of those a's, we should only have 1 a left. So here, once we divided 3a squared by 3a, we should just have a 1a left here. Now remember, whenever we have a 1 in front of a variable, we don't really need to write that 1 in front, so we can just write, we just have an a left. Then let's look at the second term here. We have a negative 9a. Remember that the sign in front of the number also always has to stay with that number. So it's not just 9a, it's a negative 9a. This number has to stay with, or that negative sign has to stay with that number. So we have negative 9a divided by 3a. Again, start with the numbers. Negative 9 divided by 3. You should have negative 3. Then look at the variables. We have 1a divided by another 1a. Anything divided by itself is always just 1, but we're taking that 1a out because we're pulling it out front. So we're just going to be left with a number. because there's only one a here, but we're taking out one a, so we're left with no a's anymore with that number. So our final factoring here is 3a, and inside the brackets a minus 3. And again, there's no more that we can do to that one, so we're finished. The second type of factoring that we're going to look at is factoring by inspection. To factor any trinomial of the form, and that's where we have ax squared plus bx plus c, so we're going to have three terms here. We need to find two numbers that multiply to get the value of a times c. This is a times c here. And that also add to get the value of b. So we need two numbers that multiply to the value of a times c, but those two numbers also have to add to get the value of b. Now there's a little note here. When the first term, that means that one that's in front of that x squared, when that first term is just an x squared, meaning that there's no additional number in front of that x squared, meaning that there's technically just a 1 sitting in front of that x squared, we can adjust these two numbers, or we can just use these two numbers to make our factors. So whenever there's a 1, we can jump straight into our factors. There's no additional steps there. That seems a little confusing. We'll see how that works out in our examples. So again, in our second example, we're asked to factor the following. This time we have the three pieces because it's a trinomial. We have an x squared, a 10x, and this plus 21. So again, you'll notice, look at in front of this x squared here. There is no number sitting in front of that x squared. So we can just do that by inspection piece. So first we need two numbers that multiply. We're going to use m for multiply. We need two numbers that multiply to the value of a times c. But our a value, remember, is just this 1. So it's 1 times 21. But 1 times 21 is just 21. So we just need two numbers that multiply to 21, but that also add, and we're going to use a for add, that add to our middle value. And our middle value, our b value, is the 10. So we need to find two numbers that multiply to 21, but add to 10. So I want you to think about that for a second. If you're struggling to try and find the two numbers that multiply to 21 but add to 10, the best trick is always to go through all the different things that will multiply to your value. So we need to think of all the different things that will multiply to 21. So let's go through some of the options. We have 1 and 21. Those two multiply to 21, but there's no way that they can add up to 10. So we know that those aren't going to work. We can also try 2 and something, but 2 times nothing nice is going to give us 21, because if we do 21 divided by 2, there's no nice factor there. It's a decimal value, so that's not going to work out nicely. So let's think about the next one. Let's go up 3. 3 times 7 gives us 21. And if we look at 3 and 7, we can see right away that we know that 3 and 7 add up nicely to 10. So those are probably our two factors. So once you have your two numbers, we know that 1 and 21 doesn't work. We know that our two numbers are 3 and 7. When we do it by inspection, when there's nothing in front of that x squared, we can directly drop it into our two brackets. So we always start our brackets off with an x out front, and then we add in whatever our numbers are. So we have a positive 3, so we're going to have x plus 3. And then because we have a second factor here, we need a second bracket. Again, we always start our brackets with x's. And because it's a positive 7, we're going to have x plus 7. So here our final answer is x plus 3, x plus 7. That is this expression completely factored because everything's in brackets and there's nothing else that we can do to factor it more. Let's take a look at our second example here. And we look at our equation. We see that there is nothing in front of this x squared, so we know that there's technically that 1 in front of it. So pull out our two factoring values, our multiply value and our adding value. So multiplying value should be the last value in our equation, the 15. And our adding value it should be our middle value, which in this case is a -8. Again, I'm going to remind you that you have to be careful whenever there is a sign in front of a number, you have to carry it with it. So because this is a minus in front of this 8, you have to carry that with the number. So our middle value, A, our adding value, is actually a -8, not a +8, because that sign has to carry with that number. So now we need to come up with two things that multiply to 15, but add to a -8. So already by looking at our two numbers, we need two things that multiply to 15, but add to a -8. We know that some of our numbers, at least one of our numbers, is going to have to be negative because we have to add to a negative value. But for our multiply value to be positive, what needs to be true about both of those numbers? Hopefully you've said that both of those numbers are going to have to be negative for this to work, because two negatives multiplied together give us a positive, but when two negatives are added together, we end up with a negative. So already we know that our two numbers are going to have to be both negative numbers. It's one thing we know about those numbers. Again, if you can't just, some people can look at this and right away see what those two numbers are. But again, if you can't, go through your different options of things that multiply to our multiply value. So looking at 15, we have 1 and 15. But again, we know they have to be negative, so we'd have -1 and -15. But that's never going to add up to our -8. So we know that one's not going to work. Go through the next one. 2 times nothing. 2 times 7.5 is what gives us 15, but we don't like decimals. We want whole numbers, so that one's not going to work. So go up to the next number, 3. 3 times 5 gives us 15. Again, we know both of our numbers have to be negative numbers. So -3 and -5. And looky there, both of those add up to a -8. So we know that our numbers have to be -3 and -5. Again, because this is inspection, because there's just that 1 in front of that x squared, we can directly jump into our brackets. Remember, the brackets always start with an x value, so we're going to have x. Then we pull in our number. Because this is a -3, we're now going to have x minus 3 in our brackets. In our second bracket, again, because we have a second number, we always start with x, but because this is a -5, we have to have x minus 5. And now that we have our two brackets, we know that we are complete, and this is our final answer. Looking at our last example here for this type, we're looking at x squared plus x minus 56. Again, we're looking at inspection because there is nothing in front of this x squared except for that one value. So we need to come up with the number to multiply to. Remember that multiply value is always just the last value in our trinomial, which in this case is minus 56. And again, remember that sign has to be carried with that number whenever there's a sign in front of that number. So we're multiplying to -56, but we have to add to, and what's our middle value here? Remember, when there's nothing in front of a variable, that's just a value of 1. So we need something that multiplies to -56, but adds to 1. Let's take a look at these numbers like we did with the last one. If we have a negative multiplied value, we know that we have to have one positive value and one negative value for our numbers, because a negative times a positive gives us a negative value. So we know we have to have one positive and one negative. Then let's look at our add value. Our add value here is 1. These two numbers have to add up to 1. If we have one positive and one negative, and they have to add up to 1, we know that these numbers are going to be really close together. So again, if you can't see those numbers right away, just go through your options. Start with 1 and work your way up to all the different things that multiply to 56. Hopefully, as you've gone through that, you see that 7 and 8 multiply to a 56. And they're really close, 7 and 8. But now we know that one of them has to be positive and one of them has to be negative. To make that, it's a negative 56. Before we decide that, let's look at our add value. Our add value is a positive 1. So we need our add value to be a positive 1. We look at our two numbers. To make our add value positive 1, it means the bigger number has to be positive. So because 8's the bigger number, that means that the 7 has to be the negative. So that when we do negative 7 plus 8, we get a positive 1. Now that we have our numbers, again, throw them into your brackets. Start off always by having an X at the front and throw in your numbers. So we have a negative 7 as our first number. So we're going to have X minus 7 in our first bracket. And because we have a second number, we have a second bracket. And it always starts with an X. And then we throw in our second number. Because it's a positive 8, we do X plus 8. Now that everything's in our brackets and we can't go any further, we have our final answer that is factored. Hopefully, if you're having any questions, the teacher can help that's supplying that can help you out. If you're still struggling with this, I will be back and you can always ask me questions when I come back. We have one more that we're going to look at today. Today we're also going to look at factoring by decomposition. Now let's just first look at the definition. Again, hopefully this should just be a review for everyone. You should have learned decomposition in grade 10, no matter which type of math you had previously taken. When we need to use factoring by decomposition, that's when that first term that we always looked at that we said was always 1 in our last examples. We use decomposition when that a value, that starting value in front of that x squared, isn't equal to 1. So this sign here means not equal to 1. So when that's the case, it means that we have to decompose, that means split up, the middle term into two smaller terms and then continue to factor. So we're still going to look for our m value, our multiply value, and our add value. But when we come up with those two numbers, we're going to have to do a few more steps this time instead of just throwing them right into our brackets. So we're going to look at some examples here. Again, we're just asked to factor the following. So we're first starting off with 2x squared plus 5x plus 3. Notice that this time we can't just use inspection because now there's a number in front of that x squared. Instead of having nothing there, which we know is technically a 1, we now have a 2 instead. So now this is how we know that we need to use this decomposition method instead of being able to use our inspection method that we just did. This time when we come up with our multiply value, just like we said in our original definition, is we have to multiply our a value by our c value. So instead of our multiply value just being a 3 this time, we need to include this 2. So now this time it's going to be 3 times 2. 3 times 2 we have is 6. So now our multiply value, our two numbers that have to multiply to 6, our two numbers have to multiply to 6, but then add, and adding's the same as before. Adding always comes from the middle number, which in this case is the 5. So our A value is 5. So we need to multiply to a 6, but add to a 5. We need to come up with those two numbers that multiply to 6 and add to 5. Hopefully you were able to see this right away because these numbers are pretty small. We know that our two numbers are going to be 2 and 3. 2 times 3 multiply to 6, but 2 plus 3 add to our 5. Now this time, instead of just throwing them right into our brackets, this is where we have to do this decomposition in the middle. So we're going to rewrite out our term. We're going to have 2x squared. And that's going to stay the same because we're not doing anything with that first term. Because remember, in our definition here, it says the middle term is the ones that we're decomposing. We're decomposing that middle term. So our first term stays the same as 2x squared. And at the end, we're going to have our last term as that plus 3. It stays the same as well. The only difference is this middle term of this plus 5x. Instead of writing 5x, what we're going to do is we're going to break it down into two pieces. We're going to break it down into the two numbers that we came up with. So instead of having a plus 5x, we're going to have a plus 2x and a plus 3x. So this is where that decomposition comes in. These two numbers, 2x plus 3x, they give us the 5x. So that still works. But now we have it broken up into these two different pieces, and that's going to help us continue to factor. So we now have 2x squared plus 2x plus 3x and plus 3. Now it says to continue to factor. So now when we have lots of things like this, what we're going to do is we're going to break it up into half. So we're going to look at the first two terms, and then we're going to look at the next two terms. And what we're going to do is we're going to see what can we common factor out. This is where our common factoring comes back in. What can we common factor out of this 2x squared plus 2x? And remember, it needs to be the biggest common factor that we can pull out. So start with the numbers. What's the biggest number that we can divide out of both of those? Hopefully you see that it's a 2. We can divide a 2 out of both of these numbers. Then look, is there a variable that we can pull out of both of these numbers? And yes, there's an x, 2 x's in the first term, and there's 1 x in the second term. So we can factor out an x as well. Remember when we common factor, the biggest common factor comes out front, and then we put everything that's left after dividing in the brackets. So start with the number here, 2 divided by 2. We know that's just 1. We have x squared. Remember that means that there's 2 x's, but we took 1 out front, so we're just left with 1x. And remember, we don't have to write that 1. We can just write a simple x. Then look at the second term. We have a 2x here, but we're factoring out a 2x. So 2 divided by 2 leaves us with just a 1. And if we have 1x here, but we're pulling an x out front, that means we have no x's left. So we just have x plus 1 left after doing that common factoring step. So that's everything to the left of that green line there. That's the first half. Now we need to do that same step for now the second half, everything that's to the right of this green line where we split that up. So again, what's the biggest common factor that we can pull out of both of these two terms? The biggest common factor that we can pull out of both of them, hopefully you see that it's a 3. Now this part's important. Whatever number you pull out, whatever sign comes with it, whether it's positive or negative, needs to stay with that number. So we're pulling out a positive 3, so we need to write plus 3. The reasoning is because it's following the rest of these terms. Whenever it follows, we have to have a sign in front of it. So we're going to write plus 3 there. Then just as before, because we factored out that plus 3 there, everything that's left after dividing goes inside the brackets. So 3x divided by 3. So again, start with the numbers. 3 divided by 3, that just leaves us with 1. But we still have that x, and we're not pulling out any x's, so we're just left with 1x, so we can just write x. Then we have this plus 3 here. 3 divided by 3, again, leaves us with something any divided by itself is always 1. So we're left with plus 1. I want you to look at this line here. What do you notice about this line after we did this common factoring in those two pieces? Hopefully you've noticed that anything that's in the brackets, we have an x plus 1 there, and an x plus 1 here, the stuff that's inside the brackets is exactly the same. This is always going to be the case in this step. So after you've done this common factoring step in these two different pieces, if what's left in your brackets isn't the same, it means that you've made a mistake somewhere. So if that's the case, you need to go back and double check to see where your mistake was. But because we have both of these brackets being exactly the same, we know that we did this step correctly. So it's kind of a nice little check for you at this point in time. We're almost there because we have one set of brackets, but we want a second set of brackets. So what we can do is, because we have an x plus 1 in both terms, we can pull that out front. We can factor out that x plus 1 out of both terms. So we're going to pull that out front. Then whatever's left after we've factored out that x plus 1, that's what makes up our second bracket. So anything that's left, we have this 2x from our first term after we get rid of this x plus 1, and this plus 3 in our second term after we get rid of that x plus 1. So that's what our second bracket is. Our second bracket is the 2x plus the 3. So hopefully you see that once we pull out that x plus 1, whatever's left, the 2x and the 3, make up that second bracket. Now that we have two brackets, we know that we're finished and we have our final factored answer. So our final factored answer is x plus 1 and 2x plus 3. Let's take a look at the second example here. And if you're needing more time to write stuff down, make sure you're asking the teacher just to pause the video. So let's take a look at our example here. We have 3x squared plus 14x minus 5. Again, taking a look at this trinomial here, we see that we have some number in front of that x squared, so we can't do our nice easy method of by inspection. We know we're going to have a couple different steps, but always start out by pulling out our multiply value and our add value. And remember, when there's a number in front of that x squared, we have to include that in our multiply value. So we're going to have to do 3 times by whatever the c value is, which is always the last number. And again, remember that sign has to be carried with that number. So we have 3 times by, there we go, 3 times by negative 5. 3 times by negative 5 gives us a negative 15. So we know that we need to find two numbers that multiply to a negative 15. Then we pull out our add value. Remember, our add value always comes from our middle term here. Let's do that in a different color. Our middle term. So our add value is 14. So we need to come up with two numbers that multiply to a negative 15, but add to a positive 14. So remember some of those tricks that we looked at before. We know that this is a negative number, so we know that we need to have one positive number and one negative number to make our multiply value a negative. This time it needs to add to a positive 14 though, which is a big number, which means our two numbers are going to be fairly far apart. Again, if you're struggling with coming up with those numbers really quickly, just go through all your different options. Start off with 1 and work your way up for all the different things that multiply to 15. So start off with 1 times 15. 1 times 15 multiplies to 15, but one of them has to be negative. So if we make the 15 negative, let's try and add those up. If we do negative 15 plus 1, that gives us a negative 14. So it gives us the right number, except that we have the negative sign out front, which isn't right. So we know that this one's not going to work. So let's try and switch those signs around. Let's try negative 1 and positive 15. So negative 1 plus 15 is equal to a positive 14, which is exactly what we want. So we know that our two numbers are going to be negative 1 and positive 15. Remember that our next step is to go back to our equation and rewrite our equation out, but instead of having that plus 14 in the middle, that plus 14x, we need to break it up into our two numbers. We start off with our 3x squared. And we know that at the end, we're going to still have that minus 5. But in the middle, now we need to break that up into our two numbers. So we're going to have negative 1x. And again, it's a negative 1 because that negative 1 carries into that sign. So that's what gives us the minus 1x. And then we have a positive 15. So we're going to have a plus 15x. So again, all we did between this and this is write out our equation, but instead of writing plus 14, we wrote in our two numbers that add up to that plus 14x. Once we've broken up those two pieces in the middle, remember we draw our line down the middle and do some factoring between those two different pieces. So let's take a look at our first two pieces here at the front. What's something that we can factor out of both of these pieces? Remember to start off by looking at the numbers. We have a 3 and a minus 1. There's really nothing that can be divided out by 3 and a minus 1, so we know that there's not going to be any numbers. Let's take a look at the variables. We have an x in the first term, and we actually have two x's because it's an x squared, and we have an x in the second term. So because we have an x in both terms, we can factor out a single x. So it gets written out front, and once we divide that out, everything left gets put in the brackets. So looking at our first term, 3, we're not factoring any numbers, so the 3 still stays the same. But here we have an x squared. Remember, because it's an x squared, that's like there's two x's. So we pulled one of the x's out front, so we're just left with one x in there. So we're left with 3x. Then looking here with our second term, negative 1. Again, we didn't factor any number, so that negative 1 still stays. But we had one x sitting there, but we pulled that x out, so we're just left with our number of negative 1. Then look at the second piece here. We have our plus 15x and our minus 5. What can we factor out of both of those? Hopefully one of you is seeing that 5 can be divided out by 15 and by 5. And again, because we're going to divide out a positive 5, we write plus 5 there. So that's our common factor that's sitting out front, and then everything that's left once we divide out is left in the brackets. So again, 15x divided by 5. 15 divided by 5 should leave us with a 3x. And negative 5 divided by 5 should leave us with a negative 1. Remember, at this point in this stage, we can double check to make sure we're doing everything correct. So we look at what's inside our two brackets here. We have 3x minus 1 in the first bracket. and 3x minus 1 in the second bracket. So we know that we're good to go so far because we know that those two brackets are exactly the same. And then remember that those two terms that are sitting out front of those brackets, they make up our second bracket in our final factoring step. So we pull out that brackets that are the same, the 3x minus 1. So you pull that out of both terms. And then anything that's left over, which is our x here and our plus 5 here, give us our second bracket for our fully factored form. And now we're done. Because we have our two brackets, we're done factoring in that example. So at this point in time, I have two more examples here. What I want you to do is I want you to hit pause on the video. I want you to take a few minutes and try to do these two factorings yourself. I want you to give it a try, see if you can complete them correctly. Once everyone has given them a good attempt, maybe you didn't quite get it finished, but you've had a good attempt, then you can click play on the video and you can see if you got the answer correctly. Okay, so hopefully everyone's given these questions a good attempt, and let's quickly go through the answers here. I'm not going to take quite as much time to explain in these ones. Let's pull out our multiply value. In this case, we have our two numbers to multiply are 10 and negative 6. So 10 times the negative 6 gives us a negative 60. And then our add value is our middle value, which in this case is a negative 11. So we need two numbers that add to negative 60 and, multiply to a negative 60 and add to a negative 11. So again, if you've struggled with trying to come up with those numbers, go through all the different options, 1 and 60, 2 and 30, 3 and 20, 4 and 15, and so on and so on. Our two numbers are going to be the 4 and the 15. But we know that it's a negative 60, so one of these two numbers has to be negative. We look at our add value. Our add value is a negative 11. So because our add value is a negative 11, it means the bigger number has to be the negative one. So when we double check, negative 15 plus 4, it does indeed give us a negative 11. So now that we have our two numbers, we rewrite our expression, 10x squared. And our final number stays the same, a negative 6. But in the middle now, we do a negative 15, a negative 15x and a plus 4x, because those are our two numbers. Now that we have those two numbers in instead of our middle number, remember that we break it in half and take a look at what we can common factor out of both of those pieces. So we have a 10x squared and a negative 15. So we can take out a 5 out of both of those, and we can take an x out of both of those. So when we divide that out, 10x squared divided by 5x, we're just left with a 2x. And negative 15x divided by 5x leaves us with a negative 3. Then we look at our second set here. The biggest number that we can divide out of both of those is a positive 2, so we write plus 2 and then divide out. So 4x divided by 2 is a 2x, and negative 6 divided by 2 is a minus 3. Again, we do our quick check. We see that our two brackets are exactly the same, 2x minus 3. So we bring that one out front, 2x minus 3. And anything that's left over once we take them out gives us our second bracket. So we have a 5x from the first term and a plus 2 from our second term. And now that we have our two brackets, we are done our factoring. Oops. Hopefully you were able to get that right answer. If not, keep trying. There we go. Let's take a look at the second example here. Now, some of you might have been a little afraid because there's H's in there instead of X's. It works exactly the same way. There's no difference. The only difference is that instead of writing X's, we write H's. So pull out your multiply value. We have our 6 from out front and our plus 5 from out back. 6 times 5 gives us a 30, so we know we need to multiply to 30. Our add value comes from the middle number, so negative 17. So we need two things that multiply to 30, but add to a negative 17. Again, because our multiply value is a 30, and it's a positive, and our add value is a negative, we know that both numbers need to be negative. So again, if you're struggling, go through your different options, 1 and 30, and so on. So hopefully you're able to come up with 2 and 15. So we have our two numbers 2 at 15, but we know they both have to be negative. And again, we can double check negative 2 plus a negative 15 does in fact give us the negative 17, so we know that we have the right numbers. Remember that now we plug them into our equation in the middle. So we still have our 6h squared, but now we need to plug in our two numbers. We have a negative 2h and a minus 15h, and then our last number still stays the same as a plus 5. And we're going to break it down the middle and look at our two sections. We can divide out a 2 and an h out of both of those terms, so we're left with a 3h minus a 1. And out of our second two terms here, I need to factor out a 5 for sure. But to make our bracket be the same, we need the second number to be negative, so I'm going to divide out a negative 5. So negative 15h divided by 5 gives me a 3h. Now it's positive, which is what we want because we need these two brackets to be the same. And then a plus 5 divided by a negative 5 leaves us with a minus 1. So in this case, this one was a little trickier. To get our brackets to be the same, this time we had to divide out a negative number in our second piece here. Sometimes that is the case. If you didn't divide out a negative number, you might have had negative 3h plus 1. So all you need to do in that case to make them the same is just divide out that negative instead. And our last step, pull out that 3h minus 1 because they're exactly the same. And anything that's left over, our 2h and our minus 5, give us our second bracket for our final answer. So that's it for the lesson today. Hopefully there is some class time left over that you can get started at some of this homework. For number 2, only do every other letter. There are quite a few in there, so just do every other, like A, C, E, and so on. And then take a look at numbers 4s and 5. So whatever you don't get done in class today is to be done for homework. And make sure that you have that done for tomorrow. Hope you guys have a great day.